There are a few variations of water softening using the chemical precipitation process. There's lime softening. There's also lime soda ash softening. There's also a process called excess lime treatment, and that's used to remove larger quantities of magnesium. And there's also a method called split treatment in addition to caustic soda treatment. Now, the caustic soda treatment is more expensive than the other method. Well, let's take a look at the most common method of softening water, and that's the single stage process. And it's very similar to a conventional treatment plant in that it starts with a coagulant added, and in this case we're showing alum being added to the rapid mix tank. And then the water and the alum and the coagulated water moves on to the flocculation chamber. From the flocculation chamber, it goes into the settling basin. And then from there, this is where we begin the softening process. It flows into a solids contact basin. And to the solids contact basin, we add either lime or excess lime and soda ash. It depends on the makeup of the water and what we're trying to accomplish. Well, calcium begins to precipitate out at a pH of 9.4. And if our hardness is primarily due to calcium hardness, we might just add lime and raise the pH to a 9.4 in this solids contact basin, and that will provide the softening for us. But if we have a considerable amount of magnesium, say greater than 40 milligrams per liter, we might use the excess lime and soda ash method, in which case we'll raise the pH to 10.6. Well, following the softening portion, where we add the lime or the lime and soda ash, we have to bring the pH back down because high pH water would cause a problem with several things. One, the disinfection process, but two, it'll cause scaling in the distribution system. So we send it through what's called a recarbonation process, and that's where we add carbon dioxide to the water, and that brings the pH down to a range of 8.6, so it's more stable. So this right here is what we'd call the single stage softening process. From here, once we've recarbonated the water, it then flows off to filters, just like a conventional surface water treatment plant, and then off to be disinfected and into the distribution system. Now we're going to take a look at the double stage process. And for our example here, we're going to take some groundwater from multiple wells and send them to the treatment plant. Because this groundwater is too hard, we're going to send them to a treatment plant and send it through a double stage process. So the first part of the process is we send it to a solids contact basin where we add excess lime. So again, because we're trying to remove magnesium, we're going to add extra lime to get the pH up to 10.8 or thereabouts, anywhere over 10.6 to get the magnesium to precipitate out. After that process, it goes through a recarbonation process where we bring the pH down, but we don't want to lower it below a pH of 9.5 because at 9.4, 9.5, that range is where the calcium begins to precipitate out. So this first step, or this first stage, we raise the pH to 10.8, and that's primarily to deal with the magnesium in the water. And then we move on to the second stage of our double stage process, and we send it to another solids contact basin where we add soda ash. Then we send it through a recarbonation process again. That's the second stage. Now this second stage where we add soda ash, we do that to remove the non-carbonate hardness. Okay, so the first stage is removing the carbonate hardness, and the second stage is intended to remove the non-carbonate hardness, and that's where we add this, or why we add the soda ash. We then recarbonate to get our pH down to the 8.6 range. This last method is called split treatment. This is a variation of the softening process intended to reduce chemical usage. And it's basically you're just splitting your flow stream. So assuming we have some wells, some groundwater that's hard, it'll flow into a flow splitter. And from there, it'll go one of two places. It'll go into the rapid mix, where we add some polymer or some type of coagulant, and then into a solids contact basin, where we add lime or excess lime, depending on what our treatment objectives are. And then it'll flow from there into the next process. But back to the flow splitter, we can bypass the rapid mix and the solids contact basin through this flow control valve, and this allows us to treat part of the water. So we're bypassing some of the flow, which is going to maintain the hardness and the alkalinity, and a portion of the flow will treat. Both flow streams meet up and go into the recarbonation process, where carbon dioxide is added and the pH is adjusted to 8.6. So the split treatment method is primarily just a way to reduce chemical costs by treating only a portion of the total flow.